Welcome back, everyone. Let's dive right into today's explainer, where we're unpacking Chapter 5 of our source material. Today, we are looking at the foundational architecture of our entire number system. We interact with numbers so constantly, from checking the time, to buying groceries, to analyzing complex data at work, that we kind of just take the underlying structure of math completely for granted. Well, today, we're going to change that.
Really think about this for a second. How exactly do we write an infinite universe of numbers using just 10 simple symbols? It is an incredibly efficient system. Whether you're counting the change in your pocket or calculating the distance to a literal galaxy, you are using the exact same toolkit. It's this structural brilliance that makes all of modern mathematics and, honestly, our modern world entirely possible.
So, here is our roadmap for this explainer. 1. The 10 magic digits. 2. The power of position. 3. Visualizing place value. And 4. Rules of divisibility.
Section 1. The 10 magic digits. Hindu-Arabic system.
The system we rely on every single day is officially known as the Hindu-Arabic number system. We use exactly 10 digits for this, 0 through 9. Now, when writing numbers from 0 up to 9, we write one digit in one position. So naturally, the absolute greatest possible number we can write using just one position is 9. But what happens when we need a number that's one greater than 9? Well, we shift. Numbers like 10 or 99 demand two distinct digits, or one digit written twice, using two positions. We literally have to expand our horizontal space.
Moving on to Section 2. The power of position. Value of digits.
Let's compare 35 and 53. We are using the exact same symbols here, a 3 and a 5, but the numbers we end up with are drastically different from one another. Why is that? It's because a digit's true meaning is entirely dependent on its location. The 3 and 35 is doing a very, very different job than the 3 and 53.
And that brings us to the absolutely crucial concept of place value. It is the specific value represented by a digit in a number, according strictly to the position of that digit. This is the ultimate rulebook of our numbering system. A 5 isn't just a 5. It's a 5 sitting in a specific chair, and that specific chair dictates its actual worth.
Section 3. Visualizing place value, beads, and abacus.
If we take 35 beads and string them into chains containing 10 beads each, you get exactly 3 complete chains of 10, with 5 individual beads just left over. This visually proves that 35 is literally made of 3 10s plus 5 1s. The 5 is in the ones place, so its place value is just 1, giving us 5. The 3 is sitting in the tens place, representing 3 groups of 10, which gives us 30.
As numbers get bigger, this whole system just scales up systematically from right to left. We start at the ones place, then tens, hundreds, thousands, 10,000s, and way beyond into the millions and billions. But here is the golden rule you really need to take away from this. Whenever two successive digits of a number are considered, the place value corresponding to the position of the digit on the left is exactly 10 times the place value of the digit on its right. It's just a continuous multiplication by 10 as you move leftward.
Let's break down a larger example, like 67,524. Starting from the right, the 4 is in the ones place, representing a value of 4. The 2 is in the tens place, representing 20. The 5 is in the hundreds place, giving us 500. Moving further left, the 7 sits in the thousands place, representing 7,000. And finally, all the way on the far left, the 6 is in the 10,000s place, representing a massive 60,000. Every single counter's value is dictated entirely by its column. And remember, the maximum number of counters you can place on any single rod is 9. Once you hit 10, boom, you clear it and move one counter to the rod on the left.
Section 4. Rules of divisibility. Mathematical shortcuts.
Think of these rules as literal mathematical cheat codes. Because of how our base 10 place value system works, you don't always have to do the grueling long division to know if a number can be evenly divided. You often just have to glance at the very last digit, the ones place. If you want to know if a whole number is divisible by 2, just check if the ones place is a 0, 2, 4, 6, or 8. To check if it's divisible by 5, the ones place must be either 0 or 5. And to check for divisibility by 10, that digit in the ones place simply must be 0. It's an incredibly fast trick, and it's all made possible by the underlying structure of place value.
And finally, the big picture, why math matters.
In the introductory notes of our Chapter 5 source text, there is a really powerful message from the Minister of Education. It points out that the rapid development of information technology and communication over the last 2 decades has just radically changed our world. To face the new challenges of this highly technological and intellectual society, mastering these core foundational concepts isn't just about passing a math test. Like the Minister of Education states, education determines your future. Grasping these fundamental building blocks is exactly what empowers you to navigate and succeed in a complex, rapidly evolving world.
So I'll leave you with this final thought. Now that you fully understand the hidden architecture behind every single number you see, how the mere position of a digit dictates its entire value, how are you going to look at the world differently? Armed with the secret of place value, what mathematical patterns will you spot in the world around you today? Keep your eyes open and keep learning. Thanks so much for joining me on this explainer.